Good morning. Thank you for joining us for CNM's Employer Roundtable and Capstone Project presentation. My name is Marlene Trujillo. I've been a student with CNM's Deep Dive Coding IoT Bootcamp for the last few weeks. I've learned a lot, and I'd like to show you some of what I've learned today. Here I have a bandsaw that I was creating so that I could hook it up to all kinds of cool IoT devices. A little bit about the device first. As you can see, I made it out of a couple different bikes. This is a piece of a washer shaft. This is how I have the fork attached, and the motor is almost ready for its motor. As you know, prototyping doesn't always go just exactly as we hoped. Here I have the motor out of the washer. I'm going to hook the chain up and put a pulley on the end and then hook the chain up so that the motor can run the saw. At the moment, just as part of the prototyping stage, I actually have it still hooked up through all the washer connections, and I can put it on spin and it'll go fast, and put it on wash and it doesn't go as fast. So it gives good ample opportunity for experimentation. When this saw is complete, it will have a dust sensor on it that automatically turns a vacuum on when it sees too much dust accumulating to help improve air quality in workplaces. It will also have a vibration sensor on the motor so that if there's any sudden failures like the blade binding up or anything getting just kind of caught in the machinery and it senses this huge shock from a sudden stop, it'll turn the motor off immediately. I'm also going to have a tachometer attached to the motor. That'll help you to know how much power you're consuming, as well as an amp meter. So you can see what machines are efficient in your shop, what machines are not efficient in your shop. Also, you can use these things to help do some preventative maintenance and hopefully diagnose some problems before they happen. For instance, if you saw a jump in amperage over time on a certain machine, you would know that perhaps you were needing to replace bearings or do some other kind of maintenance to the machine, something slowing it down, making it work harder than it should. We've been working with I2C and SpyBus communication systems. There's many benefits to these types of systems, as well as Adafruit IO and Hackster and a number of others, where not only can we collect all this useful data about how well your machine is running or not, whether or not it needs maintenance maybe, or all these other things, but you can get all this information packaged in a nice, neat dashboard or as an email if certain thresholds are met, or even as a text message. So there's a lot of exciting things happening in this field, and I really am excited to be a part of it and to be getting going on starting to build my own smart devices that I never thought needed to be smart, but will be really cool, like my bandsaw that's going to turn on the vacuum automatically for me and um, make sure that it doesn't break down without giving me a little warning, maybe. That way it works when I need it. Thank you. So, like I said about some of those really cool codes I learned, this is the RPM code that I told you could sense how fast your engine is rotating and send you some messages. Right here you can see I already have a few readings. It's a good real-time RPM gauge. So check this out and look at the screen. And you'll see it throughout the screen like, oh, in the neighborhood of 2142. So this thing goes about anywhere from 3,500 to 1,500 per minute. So that's probably about right. I've been using it some. Battery's not totally charged. So that's just an example of some of the really useful things that I learned during this camp. So now that we saw a little bit of where we're going, let's look at a little bit of how we got started. So safety first. Make sure you have your eyes and toes and fingers still attached when you're done with the cool things. So this is my initial drawing that I was kind of imagining the bike becoming the saw. This is the dryer motor that I originally sourced out of my broken dryer to run the saw, which I did get that running, by the way. This is the bike that makes up some of the parts of the saw, especially the main frame, and actually the seat post is used, and a bunch of the other stuff. That's pictures of a bunch of dryer and washer parts in the back of my truck because I took them all apart, source some parts for my project here. That's the bottom of the washer machine. You can see the motor and the transmission in there. What's after I got the wash tub out. I just thought it'd be kind of cool to see. I was like, how am I going to get this spinner out? And I thought, oh yeah, I'll use these oil wrench pliers, but they didn't work. I ended up using a hammer and a screwdriver. This is the motor that I took out of the washer, which is actually a 1/2 horsepower motor instead of a 1/3 horsepower motor. So I'm kind of want us to put that in the saw instead. It's just the taking apart process. That's the little transmission out of the washer. And that's the bike, the other bike that I used right before I chopped it in half. And doing a little bit of cutting with the grinder, trying to get that bar out of the center of that. And here we are at a loose interpretation of what we will hopefully end up at, which is a cool homemade IT savvy bandsaw. So thank you so much for your time today. If you have any questions, please feel free to email me or of course ask me right now. Thank you.